Okay, so for this integral, we have the integral of e to the cosine squared of x times sine of x times cosine of x dx, and we want to evaluate that from 0 to pi over 4. So this is going to be a u substitution problem. We're going to pick u is equal to cosine squared of x, because that'll simplify our exponential term over there. And then du, if we use the chain rule on this, we get -2 sine of x cosine x dx. And then of course we just want that sine of x, cosine of x part. So if we multiply both sides by -1/2, we get -1/2 du is equal to sine of x cosine of x. Okay, and so this is what we're going to use. We're going to have our u right there. We're going to plug this in for du. Those are our two functions. Go ahead and plug these in. Now we have e to the u and du, and then don't forget this -1/2 out here. Okay, so this step should be pretty simple. Hopefully you know that the integral of e to the u is just e to the u. Whoops. What happened there? There we go. E to the u. And then times the -1/2. And plus c. Don't forget that. And now we just want to plug our back in for u and then evaluate over our region of interest. So we have -1/2 e to the cosine squared of x evaluated from 0 to pi over 4. And that's going to be equal to -1/2 times e to the cosine squared of pi over 4 minus e to the cosine squared of 0. Okay. And this first term here, so the cosine of pi over 4 is equal to the square root of 2 over 2. And if we square that, we get 2 over 4, or 1/2. So we know that this term is equal to e to the 1/2. And then this second term, we have cosine squared of 0. Cosine of 0 is 1. 1 squared is 1. So we just have e to the 1. So we have -1/2 e to the 1/2 minus e to the first power. And then if you just plug that into a calculator, you're going to get 0.5348. And that is our final answer.